All right. Hello and welcome to Bug-Free Productions, where we create simple code for complex problems. Here we have GitHub today, so let's get into our presentation. All right, so welcome to GitHub. Let's make fetch happen. Short intro. So I am a Unity developer with 7 years programming experience in C Sharp and 4 years experience in GitHub. I have developed and managed Unity application and development teams, collaborating using GitHub and GitHub Desktop. These applications were for mobile, VR, AR platforms. In current research, I'm managing GitHub development of VR Classroom and integrating cognitive load theory and various HCI concepts and theories. Might be thinking, well, why should I use GitHub? For development reasons, this can be helpful in the development of applications for research, allowing your team to more effectively collaborate while developing tools and applications during research. For research, hosting your work on GitHub in a public repository can allow future researchers access to the tools needed to conduct replicative research and provide research results or data. Reproducibility is a major concern in research. If the means are not provided to replicate a study, it can prevent the study from being able to be replicated. This prevents further confirmation or possible rejection of research findings. Reasons for GitHub in research. So one is sharing materials, data, and code. So this could include tools you're using to to conduct the research. Two, project handoff becomes easier in high turnout for environments. So if you have a lot of people added to and removed from the project, this can be an example of, for example, grad school, how you have master's students coming in every 2 years and you have a quick changeover rate. This can help hand off the project to new incoming workers. Project management tools aid in both contribution and collaboration. Three. So they just help us be more productive and manage ourselves in a bit better. So GitHub projects would be an example of this, which projects is a tool for a repository for work distribution. Educational materials such as courses, lectures, and workshops. Four. These can be used to train or educate individuals. Also, you could run a course if that was something you wanted to do to maybe screen or help train individuals. Then there's website hosting. So website hosting could be a deployment thing. It could also just be your research website and you're trying to make your research more publicly visible. Archiving and citing. Six, archiving and citing increases reproducibility. If people can cite for research, then it is easier for them to come back and for other people to come back and find it. And peer review. So um, you could submit a paper to a peer reviewer or a publisher and leave the repository private until the publication goes through, and then make your repo public, which allows you a little flexibility so you're not showing all of your incomplete data while you're conducting research, but you have every ability to um, make it visible later. So must have and recommended resources. We have Visual Studio Code. Visual Studio Code is a light IDE that I like for using to fix my Git conflicts. Visual Studio Community is an IDE that I prefer when working with C# scripts. This is especially true because of the Unity tool plugin. GitHub account, everybody will need a GitHub account in order to use GitHub repos and other GitHub tools. GitHub Desktop is a desktop application that provides new users a GUI, graphic user interface, to kind of get them eased into the new Git workflow. Git Bash would be the install of Git on a Windows machine. So I usually run Git through Git Bash, and you can use the links on any of these to go to and download these tools or sign up for the accounts. Unity Game Engine for the demo. It's not necessary to use this one unless you are a Unity developer, but I did use it to generate some project files and use for the demonstration. So if you're interested in that demonstration, you can definitely follow along using all of these tools. So without further ado, I think we'll head on over to the demonstration. Okay, so we're going to try not to run too long with this demonstration here. We're going to have to go ahead and get our GitHub. So if you haven't done so, go ahead and sign up for a GitHub account. You can just go to github.com as you see on my screen. And here's the screen. As you can see on my screen, and sign up for an account. Once you sign up for an account, your dashboard may not look as full as this, but as long as you have this dashboard here, everything should line up correct. So first step we're going to do is we're going to go ahead and create a new repository. So we hit the little plussy, we go new repository, which will take us to a page to create a repository. Um, these steps are also listed in the slides if you ever need to refer back to them and don't want to watch the whole video. So let's go ahead and go, we'll name this something like demo, demo repo. So demo repo is a demonstration repo to learn GitHub. Learn GitHub. It is fetch. And exclamation. Here's the visibility. So once we name a repo, we give it a description, we choose a visibility. In my case, I'm doing public, but if you don't want people to see it, you can definitely use private. Here you can do .getIgnore, license type. Um, license type is fairly safe without adding a license for the most part, but if you know what your licensing is, you should add that as soon as possible. So I'm not going to add a getIgnore right away because I wanted to add that in a separate file way. So let's go ahead and create this repository. And here we'll see the little dashboards. You'll see them in my repo, demo repo, and my name demo repo. And then we're just going to go here and we'll see under quick setup, we can add some selective things. Let's do a .getIgnore. So we'll add this right away. I'm going a little bit fast just so we don't take too long. So here we would enter all of our code. Let's go ahead and just open up getIgnore. So let's find git ignore unity. And you need to git ignore. Should be about 90 lines long. So this is the right one. There is also a difference. There's many different git ignores, some for different kinds of projects. I believe there is also a link inside the slides to find for one I found earlier. So we can just copy all of that and paste it in here. This is just saying that I want to ignore these files and more files. So as we go up to here, we can go ahead and do a commit changes. This will actually save our file. So before we do that, just double check. Out of paranoia, we check the git ignore. It is .git ignore as our text, and we hit commit changes. I want to create git ignore. Just git ignore. This git ignore is still fetch, and then commit. So now we have a git ignore in here. This was important because I didn't want it to have too many of my files set up. Uh, so let's do a pull now. So what does this look like when we want to clone this repository to our local device? So when we want it to go to our local device, we're going to have to open up a GitHub desktop, which I already have opened and signed in. So if you haven't done that, you'll have to download GitHub desktop and then sign into GitHub desktop. If you haven't done any repositories before, you probably won't have this screen, but you can always go to File, Clone Repository, and it's refreshing. We can go Demo. So we can search demo repo at the path we want it to be at, and then we'll clone. Amazing. So I'm going to pause it here, and then I'm going to open, then we're going to come back to the demo with the folders open for the transfer. Okay, okay, coming back with the files open, I'm going to go ahead. You can find your repo location by going right click and then show in Explorer. Um, so we can see right here, it has the git data folder and the .git ignore. I already have mine open over here. So we can look at these. So here's the repository folder, and here's the Unity project I created that I'm going to put over into my repository for my push. So Control C, just copy all files, and Control V. And you can generate these files just by creating a new Unity folder or a new Unity project, and then navigating to the folder inside the project folder. So you go inside the project folder, copy everything inside the project folder, and paste it into your new repo folder. And this is a little slow because it's a lot of data, but while it's thousands of files in here, you'll remember the .get ignore we made to ignore a lot of files. If we go back to our GitHub repository that's cloned, all of these changes are here, but out of the thousands of files that were created and changed, you notice only 28 changes were logged. So that's what our git ignore is doing. It's ignoring all the files we don't want to transfer between machines. So let's go ahead and do a commit. Um, INITIAL, initial push. and then initial push of a fetch app. And I know that reference is old, and I apologize to anybody who no longer knows what that means. Uh, but once we do a commit, it saved all the changes we had selected here into a commit that can then be pushed to the online repository. And once we do a push, then everything should be visible on our GitHub. If we refresh the page. So this is how we just kind of share code with others while we still only make changes to our local files. So let's go from here and let's do a pull now. So what do we need to do a pull? We probably need something that doesn't exist on the local files set up. So we need to um, zoom out a little bit. There we go. I think I can do plus create new file. And I'm just going to call this test dot txt txt. So this app is fetch. So once we create it, it's not text, it's txt. Then I'll commit the changes. Um, this is a fetch test, and then we'll commit. That's right here. Whoops, didn't want to go demo repo. There we go. Stay on this page. So then if we go back to our Git desktop and do a fetch, we can see that now we found a change and we want to pull it to the repo that's locally stored. So we pull, and now if we go to our files, we have test text right here. So if I double click this, it opens on the other screen. We have this file now. So what we would actually want to do is not push to the main all the time. What we want to do is go ahead and create more branches. Um, this branch is fetch. And again, that's just drop down, create new branch. And then since this is a local branch, we need to publish it. I'm not going to create pull requests just yet. What I'm going to do is to um, go into this folder now, right? So if we go here, this now refers to this new branch since we changed branches in the GitHub desktop app. So we can double click this and open it. So this branch is so fetch. Control S and close. Now, if we go to the GitHub desktop, we'll see our test has been changed. We had this text, and now we added this text. So this branch is so fetch. Um, it really is. And then we do a commit. So we commit and we push. So this is pushed to this branch. So if we went into our GitHub, look at the branch, um, change our branch to this branch is fetch, we can see this guy's text is changed. All right, so let's look at that and go back to main. And this guy's text is not changed. So to fix this, we could either do the compare and pull request here, um, which is usually where I like to do it, but we'll do it through GitHub Desktop just to show you how that works, which it will just take you back to that page if you do create pull request from this branch fetch. It'll take you to this page where we have to open a pull request. So we click the create pull request an absurd amount of times, but that's because it does conflict checking. So it makes sure there's no conflicts before it even attempts to merge this branch. And if there were conflicts, it would prompt you to change them, fix them before merging. So now we can do a merge pull request. Maybe we'll add some more exclamation marks here. And then confirm our merge. All done. Believe? Yes. So after all of that, if we go back to our GitHub, desktop, change back to main, do a fetch, do a pull, check the files, we see that this branch was indeed so fetch. All right, that ran a little long, but we're going to jump back to the um, final rules and notes. So see you there. All right, so coming back from our Git demonstration, let's go ahead and look at some rules going forward. So based on what we saw, a few rules that would be good for GitHub are to establish a proper project management system, although we see how the workflow can be a little standardized by the capabilities of GitHub. It's still no replacement for good old-fashioned project management. Two, use branching and forks to limit conflicts. So we looked at branches and how we can create and merge branches to add possible new functionality as we develop our tools. Three, we label everything. We name branches, we name commits, we make sure everything is named so that we can easily find it at a later time and revert if necessary. Four, we take advantage of provided integration testing tools. So integration testing tools could include Travis CI, which is one that is able to be integrated into the GitHub workflow. And we raise issues collaboratively. Basically, we just want to comment and make suggestions and be as helpful as possible. Make your code citable and well cited, number 6. So we want to make sure that not only our code is citable by others, but also that we cite other people's works correctly. Uh, this is important in two dimensions. One, we want the one, we want them to be able to receive credit for their works. Two, they also um, it helps if you build off of someone's code base to be able to go back and read the original functionality of that code. Promote and communicate. So one of the most important things is probably to promote and communicate about your GitHub repository. So one thing that you can use to communicate about your Git repository is Gitter, which is an IRC, Internet Relay Chat, that is based on GitHub, but that is by no means limited to Gitter, no matter how fun it is to say. But you can also promote across your website, across social media, not just on Gitter. So summary and notes, GitHub's transparency and communication also had a social, educational, development, and issue tracking effect. Um, this transparency makes the individual contributor more visible, meaning people can more easily find individual contributors than they could when things were just published by organizations. The visibility of contributors and repositories may not only attract people who watch a repository, watchers, but also lead them to develop. So they may eventually join as a contributor after being a watcher for a certain amount of time. GitHub provides a simple platform with many simple integrated functions. These functions create the opportunity to create a collaborative, fault-tolerant, organized, modular environment for development and research. So all of these help us to establish a workflow that is both collaborative, uh, citable, and fault tolerant, which can become a really big thing, especially when you're worried about working with huge amounts of data. You don't necessarily want to lose any of it. Um, with that, that's our last slide. So thank you. And to everybody, make fetch happen.